Greetings to all. Today we are going to study the activity number 3. The objective of this activity is to find earth fault loop impedance and touch voltage and the prospective short circuit current. And also we need to verify our RCD, the working condition, by checking its trip time and also the trip current. Before conducting this activity, let us see the protective device what we have used here. So we have used one MCB, double pole MCB, and an RCD. Okay. So for the MCB, the technical specifications is ICN and IN. So what is IN? It's a normal operating current, and ICN is a prospective short circuit current capacity. So let us see the MCB what we have used here, and let us see the type also. The MCB what we have used here is C20 type MCB. And what is the meaning of C? The C means that this type of MCBs are used for commercial applications, and the trip range of this varies from 5IN to 10IN. And the number 20 denotes that the normal operating current of this MCB is 20 amperes. And what is the ICN value for this device? You can see here it is denoted here as a 6000 amperes. So that means 6 kilo ampere is the ICN value for this MCB. And the second device what we have used here as a protective device, you can see this is a RCD. So this RCD, the technical specification again, it is a IN and then I delta N. So IN here is 100 ampere, that is normal current which it can pass through the line and neutral is 100 amperes, and then the I delta N value, that is the rated residual current which can pass through this device, is 0.1 amperes. So what is the difference between this MCB and RCD? As a working function wise, the MCB looks always the line current with respect to the rated current of this device. So if the line current is go beyond the rated current of this device, then the MCB will trip. So that means if this MCB is allowing more than 20 amperes of current, this device will trip, because the rated current of this device is 20 amperes and the load current which is going through this MCB, if it increases more than 20 amperes, then this MCB will trip. What is the meaning of trip? That means it will switch off automatically. And what about this RCD? The RCD is not looking for the line current alone, and it is looking for the difference between the line and the neutral current. Okay, so whenever the line and neutral current difference is more than this 0.1 amperes in this case, so when this current is more than I delta N value of the RCD, then the RCD will trip. So the trip current of the RCD is I delta N value, and the trip current of the MCB is this IN value. Okay, so if the load current goes more than this IN value, then that means the MCB will trip. But in this RCD, whenever the difference current between the line and neutral goes more than this I delta N value, then the RCD will trip. Okay, so the third component or the third device which we used here in this test is installation tester. This installation tester is used to measure various parameters of the installation. So in this activity, what we are going to measure is earth fault loop impedance and touch voltage, short circuit current, trip current, and trip time of an RCD. So for finding this activity, for conducting this activity, first of all we need to switch on this MCB here. So let us switch on this MCB and then switch on this RCD. It is already on, so you can on like this, and then when you switch on these two devices, you can see the power is coming to the installation tester. And after this, what you have to do, you need to keep the selector switch in the ZS closed switch position to find the earth fault loop impedance and the short circuit current. Okay, So when you keep this in the ZS closed switch position, you can see the single phase voltage is appearing here, that is 250 volt in the line is appearing here. So this means the supply is coming here to the installation tester. If it is not appearing here, if it is showing 0, that means any of your protective device or maybe the main switch itself not switched on properly, right? So now let us conduct the test. So what we have to do, after keeping this selector switch in the ZS closed position switch, and we have to press this test button to find out the earth fault loop impedance. Now I just pressed it. We can wait for a few seconds, then we can get the earth fault loop impedance as 8.39 ohms. So you can see here it is mentioned Z, yes, and this is the value, and here the unit is ohms, right? So the next one is the short circuit current. Press this button more, you will get the short circuit current as 27.4 amperes. Okay, so this is the earth fault loop impedance and the short circuit current of this particular installation what we made. Now next we need to find out the trip current, trip time, and then we have to find also the touch voltage. For that we must ensure the I delta n value of the RCD which we are testing. So as I shown here, the I delta n value of this RCD is 0.1 amperes. You can see here it is 0.1 ampere, I delta n 0.1 ampere. So what I should do here in this selector switch, I should keep this selector switch in 100 milliampere. So 0.1 ampere is nothing but 100 milliampere. So you keep this here in the 100 milliampere test point. So now what we have to do, you can see also here I delta n you have selected 100 milliampere. Suppose your RCD is 100 milliampere and if you have chosen 30 or 300 something like that, that means this device is not going to give you the output. So you have to select the appropriate settings here, and then later you can press the test button. You can see the voltage, that is touch voltage in the installation. So this is 1.1. In Oman it is up to 50 volt is allowed, but here in our installation it is only 1.1. So our installation is very good in the case of touch voltage. Now we need to see the trip current. Press the more button. You can see here now 76.6, which is less than 100 milliampere. So that means our RCD is tripping before the I delta n value. So the RCD is working absolutely fine with respect to I delta n value. And then now we have to see the trip time. So trip time is 48.2 millisecond here, but our trip time for the personal protection is maximum 40 millisecond. Here it is showing 48.2 milliseconds. So in this case our RCD fails with respect to time. So for the proper RCD you must have the trip time as less than 40 milliseconds, and then the trip current should be less than I delta n value of that particular RCD. In our case the I delta n value, the trip current is lesser but the trip time is more, so RCD is not fit for using in our personal protective circuits, right? So this is how we conduct the activity for activity number 3. So from this activity we come to know that how to measure the loop impedance, and then touch voltage and the prospective short circuit current, and also whether the RCD is in good working condition or not by checking the trip current and then tripping time. Okay, so the same procedure can be done by using this card with the extension card. We have to put one more extension card, means you increase the length of the conductor. So when you are increasing the length of the conductor, what will happen? The earth fault loop impedance, that is the resistance is increasing, so loop impedance will increase. So R1, R2, that is in the ZS is equals to R1 plus R2 plus ZE. So when you are increasing the length of the conductor, R1 and R2 will increase, so that the ZS will increase. When ZS is increasing, what will happen? The short circuit current will be getting reduced, so the trip time will get increases, so which is not safer. So whenever you test your installation, you must check from the farthest place of the installation from the distribution box. You should not test the installation from the closest test point. You should keep the farthest test point from the installation, so that you get the reliable output for this testing. Okay, so this is how we are conducting the activity number 3. So by seeing this, you come to know how to perform this test. Once again, you see this is the installation tester, and we use a double pole MCB, and then we use a RCD for this test. Thank you.